Hey everybody, we're back building a Tetris-like game in Scala using GTK. We're back before I have any of it working. I just have that little demo running that has that button that you can press. I'm going into this without much knowledge about GTK. I've never used GTK before in terms of development. I don't have a good idea of how it works. I don't know how glib works that well. I have used other GUI toolkits before. I've used uh, GUI toolkits back in the day from Mac OS Classic or Carbon. Also used Mac Cocoa and the binding system there, which I thought was just absolutely fantastic. And I've also done like Win32 development and some web UIs. So I think with this, I had some idea of what I was looking for how to do this. But I didn't know how to draw anything in GTK, so I figured I'd start somewhere, and I would start with drawing a square, just a square in the UI in some fashion. I didn't really care, what all I drew in the middle, but I did want to draw a square that covered the entire extent of wherever I was able to render to see how I could get that sized according to the rest of the window. And you can see what I ended up with. And well, the sizing isn't what I want, but it did behave how I expected. I had this button here and I put it in a group with the rendering area, and it button still works and it still renders. So this is the end result I got to, and I'll go over how I got there. So coming from these other GUI toolkits, I knew I needed some way to draw something or render to a window or a control or something like that. And there was some information here that might have been useful, but honestly, I did get kind of lucky and just start typing draw and then run into GTK drawing area new. And then I was like, oh, I wonder what this is. Right. So didn't really have and then just clicked around and started there. And I'm like, okay, this is starting to make some sense to me. So I want this drawing area. It sounds like what I want. A real game would use something fancier. Well, I don't know what to say a real game. This is a game. But some games would use something fancier, like a GL or an accelerated context where they're accessing with Vulkan or OpenGL. I have some experience with OpenGL. I don't have any experience with Vulkan. I used to be a graphics developer, so I have a good amount of experience with a number of graphics techniques. So I have some idea what I'm going in here with. So I'm like, oh, that sounds like fun. I'll just use Cairo. I'm not going to use OpenGL or Vulkan. I'm just going to use Cairo because that probably satisfies all my requirements for this Tetris game. So this sounds good. Let's go with it. And fortunately, in our documentation here, it just has simple GTK area drawing usage. And this is in C. And we'll read through this, but for the most part, this is going to be very similar to what we're writing in Scala Native. Keep in mind that the Scala Native bindings that we're using are generated from the C bindings, and they reflect the syntax of the C bindings, and the types and everything that we got to do is very similar. So the code might end up looking very similar, modulo some details relevant to Scala. So what do we got here? We have a draw function. This is interesting to me because it looks like you provide it as a callback to the drawing area. But back in the early Mac days, there was your GUI toolkit was not so friendly for you. You had to schedule the drawing and acquire the context, basically like an exclusive lock of the context to do the drawing. So I'm curious about this. Like, what is going on with this? And fortunately, it describes what's going on. That this draw function is called when the drawing area first comes on screen, some occlusion events, and then you can request the redraw using QDraw. Uh, this will cause the drawing area to call the draw function again. Okay. Gives some other information about it. To receive, you need event controllers, something called event controllers to receive mouse events, and to receive keyboard events. We'll get to that later when we get to event handling. Right now, I'm just interested in drawing. So I want to draw something. Looking this into a bit more detail, I see we initialize the drawing area with a content width and a content height, but it receives a width and a height here. I'm pretty sure And at this point, I don't know, but now I do know. But when I'm writing this code originally, I don't know what this is about. But I'm fairly confident it has something to do with layout of the GUI. So when GTK goes to build the GUI into a window, it's going to adjust some sizes of things based off of constraints for the sizing to achieve probably something like the minimum. This sets the minimum, and this would be the actual based off of other layout constraints. So for now, I'm just going to give some reasonable width and height, and I'm going to draw the entire width and height as given. And let's see what that looks like. We're back at our main from before here. This is largely the same with a few minor changes. One is that we're now naming the window blocks because, well, it's not just a little example anymore. We're going to aim for some type of block-based game. We're going to start with one block, just one exciting block. I set the default size to 640 by 480. I use Sway, so I like things that lay out according to what Sway tells them, but we'll start with 640 by 480 while we figure out the orientation stuff. Then create a vertically aligned box or vertically oriented box. So this is a bunch of boxes vertically on top of each other. I set the alignment for this box. So I'm saying within this widget's area, I'm going to center horizontally and vertically the children of this box. This is fairly familiar to me from, I'd say, web UIs also have a similar concept when you're doing layout with those. And Coco had a very nice GUI constraint, layout constraint system. Coco Assist was a wonderful way to do UIs, and I'm sure Mac has evolved since then, but I'm not on Mac, so I don't know. That's why we're going GTK. But GTK so far, I'm liking what I'm seeing. Right, we got our window here. Okay, we add our box to our window. Oh, this is pretty standard. Our window contains a set of children, and we want the child to be our box that we've added. And within that box, we're going to add a few elements. One is our button element. I still want this button element there so I can verify that the event processing of this click is still working. And then the rest of this is about the drawing area. So before I go on with that, let's focus on what I'm trying to do here and what I'm not trying to do. I really just want to display something. What I'm not in scope here is game loop, any sort of game, really anything else, because I don't know enough about GTK to know how I would do this and how I would integrate it with the rest of this. So I'm trying to do a very focused experiment here. Just, can I draw a block? We create our drawing area, much as it does in the C new function for GTK drawing area, and we see it returns a GTK widget, a pointer to a GTK widget. I want to work with the drawing area type directly for a bit, so I'm going to cast it to a GTK drawing area. And we can see that we use the as pointer extension method to do so. Now we have our drawing area. I want our drawing function. So I create a drawing function from a Scala function. Now we want this to be a C function because we need function pointer to it. And there are some constraints on what happens within here, namely that we can't close over something from up here. That's fine though, because GTK kindly passes in a void pointer of data to us. Now, it is typed here as a void pointer, and I'm not using it here, but we'll see how this is used later. For now, though, we're just rendering a box, so we're going to render that box. To draw our square, we set the source RGB to the red color, define our rectangle, or define the vector of our rectangle, and then we fill that shape. That's it. The other stuff we needed, as noted in that little example here, is to set the content area width and height and associate the draw function with the drawing area. And that's right what we do here. I'm doing 640 by 480 again. I'm aiming for, the same default size as the window. This doesn't really make any sense right off the bat because we put this button here. So we can't really have the drawing area fill the entire window and be exactly the same size as the window if we have this button also stacked vertically on top of it. The button's got to go somewhere. But fortunately, it doesn't actually end up mattering for my goal there, because GTK does the right thing and expands the content size of the window essentially to fit my somewhat nonsensical request. And then we add our drawing area to that box that's part of our window, show our window, and that is it. Notice I didn't do anything to explicitly refresh the drawing area or anything like that. That is because I am relying on this aspect here. The draw function is normally called when the drawing area first comes on screen. So I would expect from this that this drawing area is only called once. And in fact, let's verify that. Only called once. So this should be called when it's first shown on screen, maybe twice if it gets invalidated by the need to resize the window to fit whatever Sway tells them, but I wouldn't expect it to be called continuously, but let's find out. Go back to SBT here, hit run. I actually know how to remove those errors in nicer fashion now. We can shut off the fortify pass in Nix, but whatever. They're not really errors. Okay, so we have our drawing function being called. So how many times did we get called? Press the button, make sure that still works. And yeah, only called once. Right. So everything is working as expected for drawing this area just once. That is not a game. As you can tell, there's really nothing exciting about this. But next time, we're going to talk about a bit more details about the event loop, or at least the event loop from the perspective of a game. How do we get this drawing area to refresh it? Animation speeds. And something I want to talk about is timelines. It's a useful concept I've applied when building something similar that did animations before that I'm probably going to apply here, especially given the somewhat continuous and discrete nature of a game like Tetris or other block games like Tetris. That's next time, though. For now, I'll talk to you all later.